Logarithm property of equality for positive real numbers a, b, and c, where b does not equal 1. The equations a equals c and log base b of a equals log base b of c are equivalent. And we have some examples. A, 4 to the x equals 1024, and b, 2 times 6 to the power of w minus 17 equals 3. And do you want more examples? We'll get back to that one. But for now, let's realize that we've had this formula previously, right? You may have seen it in the past. Log base b of a equals c, and you can convert back and forth with the exponential equivalence, b to the c equals a. In the past, you may have seen it with a k as well. Instead of a c, a k. But for this case, we're going to see it or write it with a c. Be aware, okay? In this case, we're referring to this form of the equation as a conversion. We're converting from log to exponential or exponential to log format. But on the other hand, in this case, we are defining this as applying, or referring to as applying base 10. And it's a log base 10 typically that we use. Be aware, you can apply any base. That's why it says log base v, so it's your choice, as long as it's the same base for both sides though. But what could be easier than base 10, since you have it on your calculator, right? It's the automatic button on your calculator, log. So in that case, let's use base 10 as a basic reference. So we have 4 to the x is our first example, equals 1024. Well, we can always convert this, agree? And we can find out that x equals 5. Well, this is a fairly straightforward problem, right? Because we can try it by guess and check. 4 times 4 gives us 16, times 4 gives us 64, times 4 gives us 256, times 4 gives us 1024. There it is. So up above on our screen, we previously multiplied it 2 times, so 2, 3, 4, and 5 times that we multiply the 4 by itself, agreed? So x equals 5 in this case. And once again, this is just through basic check and guess, or guess and check. So going back and forth, multiplying 4 times 4 times 4 times 4, etc., until you get the right number, agreed? But you may not always end up with the right number, so be aware of that. So instead, how about if we try applying? So spreading this out, 4 to the x, and we're going to apply log on both sides to make our life easier in the long run. So learning how to apply log. That means I have to apply it on both sides. So like when you multiply or divide to both sides of the equal sign, you have to do it to both sides. When you add or subtract to both sides of the equal sign, you have to do it to both sides. Definitely the truth goes as well for logs. When you apply a log, like in this case, you must do it to both sides of the equal sign. That way it remains a true statement. Otherwise, it will be a false equation that you're going to build up. So in this case, we build up or applied log on both sides, so it should work. Remember that a log allows us to bring down an exponent. It's what we call the power property. So bringing down the exponent, that gives us x times the log, and remember this is the base 10. That's why we don't show a number on there, right? So log base 10 of 4 equals log base 10 of 1024, but we don't have a base on there, right? So we are assuming it's base 10 always when there's no base. So that means to solve for x now, all we have to do is get rid of the log of 4. Log of 4 now becomes just a number that you can bring out of your calculator. So by pushing the log button, put the 4, close your parentheses, and hit enter. But I don't want a decimal. I don't want to work with the decimal yet. So I'll work with the log as a whole number, log of 4 in other words. And since it's multiplying with the x, we're dividing by the log of 4. What we do to one side, we must do to the other side. So going for the other side. Okay, log of 4 divided by the log of 4 technically cancels out. That leaves us with just the x. And on the other side, log of 1024 divided by the log of 4 should give us that x equals 5. And that you can check with your calculator, agreed? So your calculator, once again, let me clear this out. If you push the log button, put in 124, or pardon me, not 124, 1024, right? So 1024. Close your parentheses, push divided by, push the log button again, and write 4. Close your parentheses, hit enter, and that should give you an exact value of 4, and there it is. So notice that working with exact values gives you an exact number, otherwise you're going to end up with a rough estimate, rough decimal value in many cases. For instance, log of 4 would have given us this number, and we would have had to round it to 0.6 maybe. And then you wouldn't get exactly 5, you get something like 4.99 something, agreed? But in this case we can say it's exactly 5 since we figured it out from straightforward calculator button pushing, right? Okay, so let's go on to the next one then. So likewise, for b, we have 2 times 6 to the power of w minus 17 equals 3. So be aware in this case, we have a little bit of extra work before we can bring down the w. So I recommend you get rid of everything you can to the other side before worrying about converting or applying. So let's get rid of the 17, since that's straightforward, it's just being subtracted. Opposite is to add it to the other side. So plus 17 to both sides. Always get rid of addition and subtraction first. It makes your life easier. So that gives us 2 times 6 to the power of w equals 20, right? 17 plus 3 gives us 20. And now we want to get rid of the 2. The 2 is multiplying, so opposite of multiplication, division. 2 divided by 2 cancels out. That leaves us with 6 to the power of w equals 20 divided by 2 gave us 10. So 6 to the w equals 10. And now notice that the w is in the exponent. If we try converting, this will only make it more complex, because our exponent is the w, it's the variable. And the base is still the 6, so there will be on opposite sides. It will look like it's converted, but we would convert to a base, log base 6 of 10 equals w, and it wouldn't work out as nicely. So instead, let's choose to apply. So I'm splitting it up a little bit, making more room to apply the log. And applying the log on the left side, and likewise applying the log on the right side. Notice you have to put parentheses around everything, okay? So log allows us to bring down the exponent. Be aware once again, we must have a common exponent. In this case, it's just 6 to the power w. So it allows us to bring the w down. There we go. So we have w log of 6 equals log of 10 on the other side. Log of 10, that's base 10 of 10. That gives us just 1, right, for reference. But oh well, we'll just work it with log format. Makes it easier in the long run. So let's get rid of the log of 6 because it's multiplying with w, we're dividing. And what we do to one side, we must do to the other. So divide by the log of 6. Log of 6 divided by the log of 6, equal and opposite, cancel each other out. And now it just remains to work the other portion in our calculator. So it gives us the w equals 1.285 roughly. Calculator work time. So in our calculator, we're going to push, and let me clear this out to make it easier to see, log. We're going to push the log button, and we're going to say log of 10. Once again, ideally this gives us 10, but just for reference, we'll pretend like we didn't know that. So log of 10 divided by the log of 6. So log button again, and 6. Now let's remember to close our parentheses every single time. Otherwise, you end up with a different number, okay? Notice each time I've closed my parentheses on the right spots. Hit enter, and now it gives us 1.285 roughly, agreed? The more decimal you have though, the more exact the answer is, but in this case we're just rounding to the third place decimal. So there is our answer. If we want to do a quick check, we could always do it in this case actually. So quick check, let's see, it's 2 times 6 to the power, so caret key, and we're going to do a rough approximation, 1.285 minus 17, and that should give us something close to 3, agreed? And there we go, it gives us 2.996. Once again, because we're rounded at the end, that's why we have a rounded number, but it's pretty close to the value of 3, which is the right side at the top of our expression, agreed? So we just checked that we got the correct answer.